Okay, so recall.
Recall.
That is the inverse function.
Is the inverse function.
Not.
And make sure not is capitalized like that. Because we still think, some of you, that this is an exponent, and that's the same thing as 1 over f of x. It is not. It's a notation for the inverse function. Inverse functions are symmetrical with respect to the what line? Y equals x line? It's right there. Do you remember this property?
Yes, but I just didn't know.
Does anybody, I know it's hard to tell what this graph is, but do you remember what this graph is on the left here?
It's like 2 curved lines.
Yeah, so what curve is this that goes like this? It's an exponential. So I don't know if this probably is, I'm just thinking if I can get any points here.
2 or 3.
Yeah, let's just say it's y equals 2 to the power x. What would the inverse here be?
Log.
Y equals log of x base 2. Remember that was the inverse function of each other, yeah? What? We're not necessarily talking about logs today. We're just talking about inverses, so just relax. Okay, algebraically, we switch the x and the y around, right, to get the inverse. So do you remember how to do this from grade 12? Well, actually, first we're finding the derivatives. F prime of x is not the inverse function. That's the derivative. So, yeah, so f prime of x is equal to 3. Everybody understand that part? How do we find the inverse of that? Yes, we would go x equals 3y plus 2, and then what would we do? Solve for the new y? Yep. So 3y equals x minus 2, so y equals x minus 2 divided by 3. Therefore, the inverse function equals x minus 2 divided by 3. Does anybody know how I could write that so that it's not all over 3? Yes. Even better than x over 3 minus 2 over 3. What can that be written as? What x? 1/3 x minus 2/3. Why am I asking that? Because in the next second I'm going to actually find the derivative of the inverse. And then it's much easier if I separate like that so that I can find the inverse. So what is the inverse function derivative? What's the inverse derivative? It is 1/3. Okay, so I don't know if you're at the point where you can go, is there a relationship here?
Look at that.
Wonder. Let's wonder for a second. Okay, do you remember what one-to-one functions are? Oh, come on.
I remember that, and then I forgot it.
Yeah, it's so you know for it to be a function, there's only one. No, for the function. To make it a function, for every x there's only one y. So for the inverse to be a function, meaning it's going to be 1-to-1, for every y there's only one x. Very good. So a function y equals f of x whose inverse is also a function is called a 1-to-1 function. This is a function for which every y value corresponds to only one x value. To determine whether a function is 1-to-1, it must pass the, yes, the horizontal line test. See, it's ringing a bell. Okay. This does look funny. Okay, so we have, it looks almost like a exponential function and logarithmic function, but we don't know what it necessarily is. However, I want you to notice what's going to happen here. So as with any pair of inverse functions, if the point 10, 4 is on one function, then what would be on its inverse? Does everybody see the x and the y switches? So 4, 10 would be on the inverse. So this 10, 4 is on the inverse function 4, 10, right? The x and the y switch. That's true about any x value. Like, so I could pick, for instance, this point right here, 2, 0 becomes 0, 2, right? On the inverse. We remember this? Okay, good. And because of symmetry of the graphs, you can see that the slopes are they equal? No. They're reciprocated. So this slope is a slope of, what's the slope here? Up 1 over 3. So 1/3. What's the slope over here? Yeah, essentially you're going right 1, up 3, but really you're going up 3 over 1. So anyways, it is 3. And they're both positive, right? Okay, so because of symmetry, you can see that the slopes are reciprocals. Yes? At 10, 4, the slope was 1/3. At 4, 10, the slope was 3. Okay, so the point 10, 4 on the f function can be written as 10 f of 10, right? Does that make sense to you?
Sure.
Think about that for a second before we go on. This is going to be huge for where we're going, okay? 10, 4, or 10 is the x, 4 is the y.
Makes it way harder.
10 f of 10. F of 10 happens to be 4, but I can also write it as half f of 10. And this, just relax. The slope at this point can be expressed as f prime of 10. Does that make sense? Okay, just kind of think about that for a second, then we're going to go on. Okay, the point 4, 10 on G, so we're not calling it inverse, we're going to call it G, can be written as 4 common G of 4. Then, because f of 10 is 4, you can replace the 4's in f of g of 4 with f of 10, giving you, okay, so I'll repeat that, because f of 10 was 4, yes? What can we replace this 4 with? F of 10, and g of 4 we can replace with no, we're going to replace f of 10 is 4. You can place the 4's with f of 10, so this is just 10, yes. Yes, are we good so far? Well, I could have put g of f of 10, but there's going to be an association coming up in a second. The slope and the derivative at this point can then be g prime of okay, I'll go back because I don't want to give you the answer. I want you to try to understand this. So do you remember back over here when we were saying, oh yeah, right here. The point 10, 4 can be written as 10 comma f of 10. The slope of that point can be then written as f prime of 10. We're taking that, not this, right? The slope. Okay, so what's this going to be then? G prime of f of 10. Very good. These slopes are reciprocal so that you get f prime of 10 is equal to 1 over g prime of f of 10. I know it's a little small there. I don't know why. Okay, so let's think about this for a second. The derivative at this was what again? The derivative at g of 4 was 3. Do you see this? This was 3. And this is 1/3, right? back up here was 1/3? Yes? So they're saying, or I'm saying, that f prime of 10, which is 1/3, is the same thing as 1 over that, which is 1/3. Which is true. Why are we doing this? You have to kind of get the understanding of what you're looking for, because they're going to give you certain points, and then you have to know what you're plugging in and then to reciprocate it. You'll see in a second once we do some questions here. So basically, if we don't use tens here, we use x's, that the derivative of f of x is going to be the reciprocal of the inverse function's derivative of f of x. So x goes in, f of x comes out. Do you see when it's the inverse, the f of x comes back in? So that's why it's the input here. Do you see what I'm saying? And we're taking that derivative, and whatever that reciprocal is going to be that slope. Ooh, it's crazy. Okay. In other words, instead of writing the g prime, I'm going to use the inverse function. Okay? Or the inverse function derivative is 1 over the derivative of the inverse. Okay, it makes more sense once we know we're using numbers here. Okay. Given f of 3 is 5. So listen and picture this. 3 goes in, what comes out? 5. Do you understand that? So the inverse would be 5 goes in, 3 comes out. Okay. They're saying that the derivative when the x value is 3 is 6. They want you to find the inverse derivative at 5.
Like it's with you and then it just.
Okay, so we'll repeat what I just said. If f of 3 is 5, that means the inverse of, you guys, I'll do this function machine again. What goes in? 3. What comes out? 5. And going the other way, so the inverse, 5 goes in, 3 comes out. Got that? So we're trying to find the inverse derivative. So inverse derivative function. It's kind of a goofy way to write it or whatever. Remember our formula back here was the inverse, they do it like this, it's the same thing as what I just wrote, is 1 over the derivative of that inverse function at that. Okay, so that's equal to 1 over, what was the formula again? F prime of the inverse of that. So all we're doing here is we're putting f prime of 5, we're essentially putting 5 in where this x is in the formula. Do you see this? Yes? Yes? And what's the inverse of 5? So this is equal to 1 over f prime of 3. And f prime of 3 is 6. So this is 1 over 6. Final answer. Woo. Okay. So, you know what? It doesn't have to be extra work if you understand what this is actually doing, right? So let's go back. Let's go back to that visual. This visual here. Yes? So, does everybody see? If I know that 10 goes in, 4 goes out, and that the slope is 1/3, then if I wanted to know what the slope is in the inverse function at 4, I just have to match up the 4 in the inverse function, and whatever that slope is, reciprocate it. That's all you have to do. So let's look at this without doing the formula this time. So does everybody see, if f of 3 is 5, then the inverse, that's true. That's kind of whatever. So do you understand, if I want to find the slope when it's 5, that is is the reciprocal of when the slope is in the regular function. Like you just look at this and you can tell it's 1/6 after you get what you're looking for, right? So some people are going to have to memorize the formula and just plug it in and go. And some people will understand what they're looking for and they can just look at it and they know, oh, it's 1/6. It's pretty easy, right? Okay, so I'll give you a second to do this one. Maybe try not using the formula. Try to use common sense. Yeah, it's kind of like common sense, right? What if you know what you're looking for there? So what do we have to know here to do this question? Okay, so if we look at this, this is the inverse function of -2 derivative. So what does this -2 actually represent? So this is the input of the inverse, which is the output of the original, and this is the original. So does anybody know what the original function that will give you that? Yes, 0. Very good. F of 0 will give me -2. It's not supposed to be, they won't give you something really hard, like they'll give you something that's kind of obvious there. So let's just kind of refresh our memory here. F of 0 is -2. Why? Because if I plug 0 into the x's, I'll get -2 out of there. That means the inverse of 2 is, sorry, -2. Thank you, thank you, thank you. That means the inverse of -2 is 0. Okay. I'm just, essentially the inverse on the normal function, they're just the x's and the y's switch, right? The input becomes the output and the output becomes the input. We're good with that? Okay. So, how are we going to find the derivative though? We literally put the...
Don't do what I just said. Do you find the derivative of x upon 2 plus 2 x upon 2 plus 5 x upon 2?
Okay, so let's do that. What do we get? No, we are getting somewhere, but I would have probably went directly in. But anyways, f prime of x is?
3x squared plus 2x plus 1.
Okay, so what do we need in order to solve this?
You gotta plug in to find out what the...
No, we don't need the inverse of that. We need the slope so we can reciprocate it. What slope are we looking for? Yes. Do you see the inverse as the 0? So if we plug 0 in, we'll get the slope, and then all we have to do to find that is reciprocate it. So f prime of 0 is
5.
5. Therefore, the inverse prime of -2 is 1/5. Bam, done. 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 Maybe not. Okay. Okay. The nice thing about inverse functions of trig ratios is just the inverse of sine is inverse sine, right? So, okay, what does this 1/2 represent? The output of the original function. The original function was sine x. So we're going to set it equal to that and figure out what the output was. Or the input was, sorry. Remember, it's saying it has to be between -π/2 and π/2. And I heard π/6. That would be correct. Okay. So I'm going to write this a little bit more technical. So what this represents is f of π/6 equals 1/2. Yes? So what do I need to now calculate in order to figure out the inverse, the slope where? Huh? the slope at pi over 6. Okay, so what would I have to do in order to do that?
Find what cos is.
So yeah, so f prime of x would then be cos x. So f prime at pi over 6 is whatever cos of pi over 6 is, which is root 3 over 2. Bam. Therefore, the inverse derivative of 1/2 is 2 over root 3. Done. Bada bing, bada boom. Okay, now that we use the derivative to find the slope of the function, this observation leads to the following theorem. The derivative of inverse functions. If f is differentiable at every point on an interval I, and df dx, which stands for the derivative, is never 0 on the interval, then f has an inverse, and the inverse is differentiable at every point on the interval f of I. So all it's saying is the reason why we can do this is because of this theorem here, right? Okay? So we can answer this. Does y equals sine x plus 1.1x have an inverse? So according to this function, this theorem, what do we have to do here? If f is differentiable at every point on the interval, and d of f is never 0 on the interval, then it has an inverse, and the inverse is differentiable. So let's find the let's find the derivative and see what it is. So what would the derivative be? No, the derivative of this would be cos x plus 1.1. So let's look at this and think about this for a second. It's saying if f is differentiable at every point. Can you agree that it's differentiable at every point? Okay, it is, for sure. Does that make sense to you? It's a wave, so it's differentiable at every point. Yes?
Yeah.
Okay, so, well, plus a line, essentially, yeah. Yes, but then we're also adding 1.1x to it. So it's a little bit goofier than the wave that we think normally. But, and the derivative is never 0. So this is the kicker here. Can I prove that the derivative is never 0? And you might say, well, you can find a derivative of cos that's 0, for sure. But then you're adding 1.1 to it. That's right. What's the lowest that the derivative of cos x could be? -1. And then if I add 1.1 to it, it would always be positive no matter what. So that means then I can conclude that the inverse is also differentiable at every point. So how do I write that? I could say...
Therefore, why is it sine?
I would say since there...
Since there
we kind of said it. Since... cos x minimum point is -1. Minimum point is -1, and we are adding 1.1 to that. There is never 0 on I. Something like that. Okay, so if you look at the assignment, I don't know if you are, it's only 3 questions in the textbook because there's a very short thing in the textbook. However, I do have a worksheet that I created that's even better. But I would still do the 3 questions in the textbook. Now just notice that they're on different pages if you look at the solutions.